So we just went through the dimension reduction and clustering technique for unsupervised learning algorithm. Now we will start a very basic and brief idea on reinforcement learning. You see, in previous cases, we are not using just like in previous cases, we are not using a group of labeled or unlabeled example to train a model. What we do, we use as a framework for decision making task by performing multiple sequence of action. What does it mean? You see, first thing is that this reinforcement learning, we basically use, our brain uses reinforcement learning every day, every time. That's why this reinforcement learning is going to be extremely vital for future. So we have a lot of different applications for reinforcement learning. A very well-known example already is almost in the market, which is self-driving car. What it does, it has some it has a so wonderful feature that it can decide that in which side it has to move, which speed it has to go through, and many more parameters, right? Question is that where the brain is, who is deciding? There must have some brain within the car, right? Who is deciding all these things? And remember one thing, that each and every brain can operate only when it gets some data. For example, for example, our brain can work only when it receives some input from different part of our body, maybe through eye, or maybe through skin, or maybe by smell, or something like that. So these are all receptors in our body, right? So if you assume that your body is something like a black box, then nose, ear, eye, skin, all these are inputs. Those inputs, the input holes. Through those input holes, some input comes from outside and it sends to brain. Brain process the data based on what brain already learned. It produces some action through some other part of the body, maybe through hand or something else, and it happens. Now you see, in our case, if I say how reinforcement learning is present in our case, just assume a situation that you when you started trying running a bike cycle, initially you didn't have the balance, right? You didn't know that how good you have to how pressure you have to put in the right hand side as well as the left hand side. So many times it happens that you basically fall down from the cycle when you are trying to run it. But day by day, what happened? Automatically the balance is adjusted in your body in some way so that you don't fall down anymore, right? So just assume a situation that you know you are an object and you have an environment, an outside environment, right? What you are doing, you are basically trying to run the bicycle by some actions. Actions means giving some paddling from the right and left leg and something like that. Based on the action that you have given, either you fall down or you run. If you fall down, that is what you can assume that as your punishment. Like, your brain learns that because of this action, this type of output generated. In this way, in continuous manner, with this set of action and corresponding output that you got, your brain basically learned how good your action should be so that you can get best result as an output. So what the best result in the form? You see, so the situation is something like this. That the concept of, as I told you, that a concept of reinforcement learning is very similar where human learn. So just assume that you are here and you have some environment. Environment means you are trying to run on a bicycle, so the road on which you are trying, that's the environment. You are giving some actions to the environment, and based on that you are getting some output. Technically, we call it as a reward value. Okay. So this particular diagram represents everything about machine learning. How? Like, we have a decision making agent. Which is decision making agent in my case? Obviously my brain. What I am doing? I am giving some action to the environment. Based on the action, at that point of time, when I am giving the action, I am in some state. Some state. Some state in the sense? In the sense, say for example, you have just started running a bicycle. You have given your pressure on right pedal. So that is your state. So, and you have given pressure, that is your action. So your right leg is somewhere in some place, that is your state. You have given the action, that's pressure. Based on that, if you don't have much balance, so initially definitely will fall down, or maybe your handle will not move properly, right? So this is what your reward value is, technically what we call in reinforcement learning. This reward value can be in form of negative value if you do something wrong action, maybe a positive value if you do some correct action. So basically what you do, based on this action reward pair, your environment state changes, and what you do, you reach your destination. Just assume a situation, instead of environment we have this chess. We all play chess, and sometimes we have a lot of apps actually where you can play chess with a machine. What the machine is? Machine is definitely that chess playing agent. What this chess playing agent doing? This chess playing agent is basically giving some actions. Actions in the sense forwarding some particular, either king or queen or something like that towards you, right? And based on that, you are also doing some movement. And based on that, either it's a positive move for the machine or a negative move for the machine. So naturally, initially, what may happen? The machine will fail in front of you. But day by day, once machine will go through several chess tournaments or chess matches, the chess playing agent or the AI box which is playing in other side will learn what should be the optimal move for him. It's a very interesting one how it happens. Anyway, it's not a very easy one. It's very, I will not say tough, but I will say it's very crucial and critical. So we need lot of mathematical background for understanding how reinforcement learning works. So I'm not going in detail of that. So I'm just trying to telling you that what exactly a machine reinforcement learning is and why it is useful. So it's something like this actually. I just what I said that you are in some state. Right. You give some action and you will get some reward. But you see, the time changes. You are in some t at some th time, you have given some action and you are getting some reward at the next time, which will be useful for the next state and action. So we have a state action pair, you see, right? Right? So you see, it's something like this that we are in state zero. I mean, at zeroth time, we are in some state, we have given some action, we are rewarded, which is basically, change the state and the action for the next time. And again, something is rewarded, again, change the state and action. In this way, what happens that a machine can understand how to interact with the environment by some successive trial and error and failure. As I said here, you see that reinforcement learning is used in application that the machine must takes sequence of decision, and these decisions come with positive or negative consequences. Obviously, when you have no information about the environment, you will basically have a blind guess, right? For example, you don't know chess playing. What do? You will have a blind guess. You will put anything towards the other opponent, right? And maybe opponent will do some move. So initially you will start losing the game. But what happens that it will be learned in your brain that because of this move you had this issue, and naturally in future, before you go for that move, your brain has been tuned which move will be best in that situation. So the cumulative knowledge of how to achieve a specific goal is reinforced. So that's why I'm reinforced again and again by experience. Again, this experience come because of this by set of state, action and reward pair. Okay. So I'll not go in any more detail of reinforcement learning. I mean, just a very overall idea we have given. So what basically we have completed till date, we have seen what is the different type of, we have first tried to understand what exactly a machine learning is. Then we have seen what are the different type of machine learning is there, like supervised, unsupervised, and reinforcement. Then we have a little more knowledge on uh, supervised learning. We have gathered some knowledge in unsupervised learning and some knowledge in reinforcement, a very basic knowledge. So with this amount of, you know basic knowledge on these three categories, now what I have planned, I will show you the different type of algorithm, machine learning algorithm, with the help of a end-to-end machine learning project. It's something like this. So we will start with the end-to-end machine learning project steps. What are the project steps? If I go through, these are the set of project steps. So what we can do? We can go for each and every step, and we will basically go through each and every step of the project, and also we will code, we will write program for each and every step. And during that time, I hope the more details about the machine learning algorithms will be much more clear to you, and you will be able to write the algorithm machine learning problems very easily.